Hello, this is Dave Marshall, and today I'd like to teach you about Kirchhoff's current and voltage laws. Gustav Kirchhoff was a German physicist born in 1824. Kirchhoff discovered that in a series circuit, if I had a 12-volt battery, the sum of all the voltage drops in the circuit will equal the total applied voltage, or 12 volts. This is called Kirchhoff's voltage law. He also discovered in a parallel circuit, if you sum the current used in each individual branch, it will equal the total current. This is called Kirchhoff's current law. In a series circuit, the current flowing through every series component is equal. That means if one draws 0.34 milliamps, all of them will draw 0.34 milliamps. Also in a series circuit, the resistance is equal to the sum of all the resistors. So if I added the 3 resistors in this circuit, they would equal the total resistance, RT. And lastly, as stated before, the sum of all voltage drops is equal to the total applied voltage, Kirchhoff's voltage law. You can see here in this sample, I've got a series circuit with 3 components. I've taken a digital multimeter and put it to voltage, and I've placed it across each component measuring the voltage. If we sum all those voltages together, they should equal my total input voltage, which is 12 volts. So here you can see on the calculator, I'm putting in the voltages, I'm summing them together, and they should equal 12 volts, which they do. So now I've taken an amp meter and placed it across each component or in line, and I'm measuring current. So if I add all my resistors together, and using Ohm's law, I take the voltage and I divide it by the resistance, I should get the current, which should be 0.006 amps, or I should say 6.5 milliamps. Now let's look at a parallel circuit. The voltage in a parallel circuit is equal across every component. So if I start with 15 volts, every component will have 15 volts. This is where it gets a little tricky. The total resistance in a parallel circuit is equal to the reciprocal of the sum of the reciprocal. There are the equations. We'll do a sample later. And as stated before, the sum of all the currents in each branch is equal to the total current. This is called Kirchhoff's current law. Remember, in a parallel circuit, the voltage across each branch should be the same. I'm checking it here with a digital multimeter, showing that they each have 15 volts. At this point on the calculator, I'm going to take the resistor values and I'm going to divide them by 1. So I have 1 divided by 470 plus 1 divided by 2,200 plus 1 divided by 3,300, which is the reciprocal. And I'm going to take 1 divided by the sum, which is a reciprocal of the sum, which gives me 346.59 ohms. That's my resistance total. If I divide that by the voltage, 15 volts, I'll get the current. The current here is 0.043 amps. So if I take a look at the current that I have out there on my meters, and I sum all those together, so 0.0319 plus 0.0068 plus 0.004, they should equal 0.043. You can see here that the two are exactly the same, which is Kirchhoff's current law. Hopefully this short little lesson taught you a little bit about Kirchhoff's current and voltage laws. Remember, you can always go back in the video and review and pause.